molecules of the cell have been on edge for days. The cell has always been a vibrant place to live and work, but that is all in jeopardy now due to a threatened walkout by the Transport Protein Workers Union, which has been able to secure a satisfactory contract from the Cellular Membrane Transportation Authority, more commonly known as SMTA. SMTA oversees all business as a plasma membrane, which forms the outer board of the cell. The plasma membrane incessantly bustles with the activity of molecules entering and leaving the cell. Much of that activity is critical, and it is not known how severely a strike by the TPW will affect life at the cell. Many molecules are turned into their local TV news stations, desperate to hear the latest, when the following breaking news report interrupts the regular scheduled program.
In the newsroom of Channel 2 Organic News with a live special report. The Transport Protein Workers Union, or TPW, have just held a press conference where they announced that they will strike against midnight tonight. Between the TPU and the CMTA have broken down, so they will talk the schedule at this time. Chloe Esterol is standing at the plasma membrane. Chloe, what's the latest?
Talks with the TPWU have indeed broken down as of 10 a.m. this morning. Those talks were reportedly marked at times by heated and occasionally emotional exchanges from both sides. The TPWU has announced that they will strike beginning at 12 midnight. What that means is that all transport through any type of transport protein, whether by diffusion, facilitated diffusion, or active transport, will be shut down at midnight. The phospholipids, who are represented by a different union, will remain on the job. As a matter of fact, the phospholipids are directly behind me. You can probably hear them now because, as you know, when the phospholipids are at work, they are constantly chattering and chanting.
We are phospholipids. We are part of the plasma membrane. We let some things pass through, but other things cannot. Some things can pass, other things cannot. Some things can pass, other things cannot. Some things can pass, other things cannot.
The phospholipid chants, of course, have to do with their selectively permeable capabilities. And as I've already stated, the phospholipids are expected to remain on the job in the event of a strike by the TPW. Now the TPW is asking for better working conditions. They say they work long hours without a break. They say they have difficult jobs shuttling important molecules across the plasma membrane. And quite frankly, they feel they are not adequately rewarded for their efforts. Some transport proteins have claimed that the phospholipids receive all the attention and enjoy much better benefits due to their sheer numbers. Earlier I caught up with Polypeptide, president of TPWU, and this is what she had to say. Do you realize the dramatic effect a strike at plasma membrane will have on the cell?
We do. Given the extreme pressure we're under, we feel this action is warranted. Our transport proteins work hard day and night and day. We're reliable. We are always there taking care of business. We deserve better working conditions and a lot more respect for our dedication in viral role in membrane transport operations.
Phil, this morning I also spoke with some of the molecules that will be affected by the strike. Here's what they had to say. What is your name?
I'm a water molecule.
How will you be affected by the TPWU strike?
I use diffusion, but I'm small enough to cross the plasma membrane directly through the phospholipid bilayer, so I can get back and forth that way all right. My problem will be the aquaporins. If they shut down, I could be in trouble.
Hello, would you like to give our viewers your opinion on the strike?
Yes, hello. I'm carbon dioxide. I enter and leave the cell by diffusion. I pass directly through the liquid bilayer.
So you will not be affected by the strike?
No.
And you are?
I'm O2. I'm oxygen, and I also enter and leave the cell by diffusion. I can pass directly through the liquid bilayer, just like my friend CO2.
We can pass at any time, yeah.
What is your name and how will you be affected by the strike?
My name is Glucose. I enter and leave the cell by facilitate diffusion. So I have my own transport protein across the plasma membrane. You know my transport protein recognizes me and only and only me and no one else. I have my own personal entrance. All the glucose molecules do.
Thank you, Chloe. With us now is Mr. Gene Gnome, spokesperson for the cell.
Please call me Jean.
Okay, Gene. Is it Gene? What is the cell doing to avert the strike?
The cell is acutely aware of the magnitude of the situation. We have been present during talks with the TPW, and we will again return to the table as talks resume short.
Specifically, what are you going to do about the TWPU and the CMTA to reach a compromise?
The cell has always held a strong belief in fairly compensating all of our cellular workers. We believe that it is in the best interest of all involved that a strike be averted, and we firmly believe that an agreement can be reached in the time for that to happen.
Gene, thank you again for your valuable time.
You are welcome, Phil.
Thank you, Chloe. We now have a viewpoint on the consequences of the strike. We have with us live feed Professor Tosol of Cell University. Professor Tosol, welcome. We appreciate you talking to us at this time.
Thank you, Phil. Glad to be here.
Can you explain to our viewers exactly what the impact strike of TPW will have on the cell?
Well, we know the strike will have a direct impact on several major functions within this plasma membrane. These functions include diffusion, facilitated diffusion, and active transport.
How will diffusion be affected? I thought diffusion involved the phospholipids only, which are not part of the strike.
First of all, diffusion is the passive movement of molecules from a high area of concentration to a low area, to low concentration. While it is true that diffusion can occur directly through a lipid region of the bilayer, some, but not all, substances cross that way. Most ions, for example, require a type of transpermeable protein called pore or channel. They can't move directly through the phospholipids. Water, of course, is very important. Small amounts of water can pass directly through the phospholipids, which shift about due to the fluidic nature of the bilayer. Water also passes through the aquaporins, special water channels that are transmembrane proteins. In fact, this is the main route for water entering and exiting the cell. The aquaporins are critical for osmosis to occur.
You mentioned osmosis. What is that?
Osmosis is the passive movement of water through the plasma membrane. It occurs to keep a constant balance of water in the cell relative to its environment.
So you mean like it will move in and out of the cell depending on external conditions?
Yes, if the cell is hypotonic conditions, then there is too much of some substance, for example salt, outside of the cell, but not enough water. There is extreme. Too much of the water may leave the cell and it will shrivel out and die.
Yeah, we all remember the Great Dehydration scare a few years ago when a stomach virus took its toll, affecting cellular communities far and wide. So what are the hypertonic conditions?
Yes, of course. The stomach virus was quickly eliminated, but osmosis is critical to maintaining water balance. Now under hypotonic conditions, we have the opposite situation. Excess water floods the cell, causing it to expand. Too much of this, and the cell could burst, killing it instantly.
Professor, the scenarios you're describing are dire consequences for the cell unless the strike is averted.
Yes, Phil, I would have to agree with you on this assessment. Ideally, we want isotonic conditions, which is a nice balance of water on both sides of the plasma membrane. To achieve that, the aquaporins must function properly.
Is there anything else our viewers should know?
Well, if the strike does proceed, facilitated diffusion would be another good cause.
Well, if the strike does proceed, facilitated diffusion would be what processes does facilitated diffusion take place?
Facilitated diffusion is the passive movement of molecules across the plasma membrane that is aided by transport proteins. Without facilitated diffusion,
That would be very bad for obvious reasons, Professor. Everything you've discussed so far has been described as passive moment. Why do you call them passive?
Because they don't require energy. Diffusion, facilitated diffusion, and osmosis are all passive because the cell does not require energy to drive the process. Active transport between, however, does require the cell to expend the energy, usually in the form of ATP energy.
And does active transport require the use of transport proteins?
Yes, it does. So this is yet another function that would be lost during the strike.
What kind of molecules cross the plasma membrane of active transport?
The sodium-potassium pump, for one, is a transport protein that needs ATP to run. That's a type of active transport that moves sodium and potassium ions across the plasma membrane. Regulation of sodium and potassium concentrations is critical to the survival of the cell.
Well, this has been very enlightening. It seems that the cell will be in a great deal of trouble if the transport protein worries on the strike. Thank you for your time, Professor Fulsel.
You're very welcome, Phil. I'm glad I could help.
We now return to Chloe Esterol.
Here's the molecule on its way into the cell now. You look concerned. How will you handle the strike?
Being an oxygen molecule, I can cross the plasma membrane. The problem is what kind of chaos will I find once I get inside the cell? I mean, cellular respiration requires both myself and glucose. If glucose can't get in, how can I do my job?
Phil, a lot is resting on the continuation of talks between the TPW and CEMTA. This is Chloe Esterol, Channel 2 Organic News.
Thank you, Chloe. We now have with us Mr. Gene Noe, spokesperson for the cell. Thank you for joining us today.
Thank you for joining us today. Please call me Jim.
Okay, Gene. Is it Gene? What's the cell doing to avert the strike?
The cell is acutely aware of the magnitude of the situation. We have been present during talks with the TPW and we will again return to the table as talks resume shortly.
Okay, what's specifically being done to the cell for the TPW and CMTA to reach a compromise?
The cell has always held a strong belief in fairly compensating all of our cellular workers. We believe that it is in the best interest of all involved that is.
Once again, the TPW and the CMTA have announced to return the bargaining table in an attempt to avert the strike scheduled to begin at midnight. We will continue to bring you live updates and information that are available.
Okay. At 9:35 p.m., a live press conference was broadcast to the molecules of the cell announcing a resolution between the Transport Protein Workers Union and the Cellular Membrane Transportation Authority.
We have just heard a live press conference where it's announced that the strike has been called off. The TPW has agreed to contract with the CMTA. Reporter Chloe Esterol is live at the press conference.
Phil, the TPWU has announced that they will sign a new contract with CEMTA. All of the details of the contract have not been released yet, but according to Gene Noe, the spokesperson for the cell, a major part of the agreement involves a collaboration between the cell and CEMTA to ensure that the transport proteins receive the attention and recognition they deserve in all biology textbooks. So in fact, biology students everywhere will learn about the vital role of transport proteins in the plasma membrane and their importance to operations in the cell. This is Chloe Esterol reporting live on the edge of the plasma membrane, Channel 2 Organic News.